Memory based question of CSIR-NET and question number 17, and this question is from part B. Question is modulus of e power z is equals to 1 for z is equals to x plus iota y, and in this question which of the following statement is true? Actually, options are x is equals to n pi, x is equals to 2n plus 1 pi upon 2, and y is equals to n pi, and so on, and for some integers n. And in this question we have to find out the best option out of given 4. Actually, in this question we have to find out the value of x or y such that this equation satisfies, that is, this left hand side equals to right hand side. Now come to explanation. As we have given that modulus of e power ez is equals to 1 for z is equals to x plus iota y, say this equation 1. As we know that if mod of z is equals to 1, this implies that square of mod of z is equals to 1. Using this result, this implies that square of this is equals to 1. Say this equation 2. Now from 2 we have square of modulus of e power x plus iota y, because z is equals to x plus iota y. Now further this implies that modulus of square of modulus of e power x into e power iota y. As we know that e power x plus iota y can be written as e power x into e power iota y. So using this here, this implies this. Now as we know that e power iota y is equals to cos of y plus iota sin y. Actually, this for every y belongs to R. This is a Euler theorem in number theory of modulus of e power x into cos of y plus iota sin y is equals to 1. Now this implies that square of modulus of e power x into cos y plus iota e power x into sin y is equals to 1. Now as we know that e power x plus y is equals to e power x into e power y, so using this implies that square of modulus of e power x into cos y into e power iota e power x into sin y, this is equals to 1. Now in a complex analysis we know that mod of z1 into z2 is equals to mod of z1 into mod of z2. So using this this implies that this and this is equals to 1. Now say this equation 3. Also, as we know that z is equals to x plus iota y, this implies that square of mod of z is equals to z into conjugate of z. This is equals to x square plus y square. We can verify this, and further implies that mod of z is equals to square root of x square plus y square. Now come to option A. In option A we have given that x is equals to n pi for some integer n. As we know that for this option we have to verify that modulus of e power z is equals to 1, and this implies that equation 3. So to verify this equation we just have to verify equation 3. So using 3 for x is equals to n pi, we have this into this is equals to 1. Now as we know that e power iota theta is equals to cos theta plus iota sin theta, and this implies that mod of e power iota theta is equals to square root of cos square theta plus sin square theta. This further implies that 1. So using this result, in this we have e power iota e power n pi into sin pi is equals to cos of this plus iota sin of this. Now using this we have square of modulus of e power iota into e power n pi into cos y is equals to cos square this plus sin square this, and this is equals to 1. It's a general rule. Now this implies that use from here square of modulus of e power n pi into cos y, this value is equals to 1 is equals to 1. Now for this we have to verify is this is true or not. This implies that square of mode of e power n pi into cos y is equals to 1. Actually, in general, this equation is incorrect because here y is arbitrary, and for every integer n, e power n pi cannot be equals to 0. This implies that option A is incorrect. Now come to option B. In option B, we have given that x is equals to 2n plus 1 pi upon 2 for some integer n. If we put x is equals to 2n plus 1 pi upon 2 in a previous case, on the same line we have square of modulus of e power 2n plus 1 pi upon 2 into cos y. That in general incorrect because y is arbitrary here, and for every integer n, e power 2n plus 1 pi upon 2 not equals to 0. This implies that this whole equation, this whole term cannot be equals to 1. This implies that left hand side not equals to right hand side. This implies that option B is incorrect. Now come to option C. In option C, we have given that y is equals to n pi for some integer n. Now using 3, we have square of modulus of e power x into cos n pi into square of this is equals to 1. Now as we know that cos of n pi is equals to minus 1 power n and sine of n pi is equals to 0, where n belongs to set of integer. This further implies that square of e power x into minus 1 power n into modulus of e power iota e power x into 0. This whole term 0, and we know that e power 0 is equals to 1, and we know that, and this term equals to 1, and this term cannot be equals to 1 because e power x into minus 1 power n cannot be equals to 0. If this term cannot be equals to 0, this implies that e power x minus power n cannot be equals to 1. So implies that this whole term cannot be equals to 0, but right hand side we have 1. This implies that left hand side not equals to right hand side. This implies that option C is incorrect. Now come to option D. As in option D, we have given that y is equals to 2n plus 1 pi upon 2 for some integer n. Now using 3, we have square of modulus of e power x into cos of 2n plus 1 pi upon 2 into square of e power iota into e power x into sine of 2n plus 1 pi upon 2 is equals to 1. As we know that for cos of 2n plus 1 pi upon 2 is equals to 0, and sine of 2n plus 1 pi upon 2 is equals to minus 1 power n. Now using these entries in this equation, we have square of modulus of e power x into square of this. As we know that using Euler theorem, this whole term converted to equation, that is this whole term converted to value 1, and this converted to e power 0, this is equals to 1. So left hand side is equals to 1 and left hand side is equals to right hand side. So option D is correct. That is option A incorrect, option B incorrect, option C incorrect, and option D is